Hi cohort. I'm going to try to do problem number 13 from chapter 13 from our homework set to demonstrate the steps for hypothesis testing. So let's take a look at the problem here. So in this problem, we have a situation where they think that if people take this test that they're about to give, that the average score is going to be 20. Here's problem 13. So they think that the average score on this test is going to be 20. And what they've done is they've given this test to a random sample of 5 college students, and we notice that all of their scores are greater than 20. And so the question is, does this sample give us evidence that the population mean really should be higher than 20? In other words, that college students on the average do better than just guessing. So that's the test we're trying to run. So the first step in hypothesis testing is to check some assumptions, but I don't think we're doing that in this class, so we're just going to jump to step number 2, which is to set up our HO and HA. So I'm going to open a Word document so I can write our HO and our HA. So our HO is the null hypothesis. It's what we believe is true. So we believe that the mean is 20. So our HO is mean equals 20. The null hypothesis always has an equal sign in it. Your alternative hypothesis, you think that college students in general might do better than guessing. That means the mean is going to be greater than 20. They do better than guessing. Step 3 in hypothesis testing is to compute a test statistic, and step 4 is to compute a p-value. And this is where I really would recommend strongly that we use technology to do both those things. So again, I have a calculator here on my computer that I'm going to demonstrate. You can download this calculator from the internet. You could get an app for your phone. Oops, interesting. Hold on. Try to open my calculator again. Okay, so you can get an app for your phone, you can get an app for your iPad. I could lend you one of these, but really I highly recommend getting some technology, portable technology that you can use for the class. Okay, so what I'm going to do is I'm going to turn my calculator on, and I'm going to enter the data that I have in the problem. So the data is 5 scores. One is 31, one is 24, one is 21, one is 25, oops, and the last one is 32. Okay. Now I'd like my calculator to run a statistical test for me. So over here we have our option for tests. And the test that we were running is a t-test because that's the test to use to test a claim about a mean. All right. Now my calculator wants to know, do you have data or do you have stats? Now if I had highlighted stats, my calculator would want to know a sample mean and a standard deviation. And I could have calculated those, but I didn't. Instead, I took my calculator and I entered some data. So I'm going to leave it on data. My calculator simply wants to know, first of all, what number is in your null hypothesis? So this little 0 means check your null hypothesis. So if I look at the null hypothesis we wrote, the null hypothesis has the number 20. So I'm going to put the number 20. Calculator simply wants to know where's the data. My data is in my list 1. The frequency just means count every number once. Here, what the calculator would like me to enter is what sign do I see in my alternative hypothesis. So in my alternative hypothesis, I see a greater than sign. So I'm going to come over here and I'm going to highlight greater than. Now you can choose to either calculate or draw. If you calculate, your calculator will give you a long list of numbers, one of which is the p-value. I always like to draw because it'll help me explain the p-value a little better, and plus because I just like to see what's going on. So the calculator draws a bell-shaped distribution, and down below it's going to return a test statistic and a p-value. So the test statistic right here, this 3.1252, that's what you would get if you use that formula in the book, number minus mean divided by standard deviation divided by square root n. So that's your t. And then your calculator gives you a p-value of 0.0177. Here's the idea behind the p-value. Remember we talked briefly about numbers or test statistics which are unusual? What my calculator is telling me is that I'm 1, 2, 3, and a little bit higher than the believed mean. Anything above a 2 is unusual. And what my calculator is telling me is that, see that tiny, tiny, tiny bit of shading right over here on the right-hand side? That corresponds to 0.01. What that means is I have really strong evidence that my null hypothesis is not true. See, if my null hypothesis was true, then the mean should be around here. If I had sample data over here or over here, somewhere in the neighborhood of this observed mean or presumed mean, then I wouldn't think it was unusual. But my sample data is way over here, over 3 measures of spread away from my mean. That's highly unusual. How unusual? I have a p-value of 0.01. You can kind of think about it like there's only a 1% chance of seeing a sample that unusual. So what we're going to do is we're going to reject our null hypothesis. So I'm going to come over here. I'm going to reject my null hypothesis. Evidence suggests that the mean is greater than 20. In other words, evidence suggests college students do better than just guessing. I really recommend this approach with a p-value instead of using a table and establishing a critical region. If you're wondering how it compares with that, what the table and the critical region do is they establish some kind of cutoff, like over here somewhere. And if your test statistic is bigger than that cutoff, you reject. If your test statistic is smaller than that cutoff, you don't. But if you're reading any literature, any quantitative articles for that matrix we're doing for Patricia and Irina, all quantitative literature refer to a p-value and a test statistic, and none of them refer to a critical region. So this is the more modern approach. People have done this probably since the advent of technology, and so it makes hypothesis testing really a breeze. So highly recommend getting some kind of technology to help you do the test statistic and the p-value, and not really stressing over the tables. Okay, hopefully this is short enough to post to YouTube. We'll see you in a moment. If you have any questions, feel free to email me, and I'll see you on Saturday, and we talk more then. Okay, bye.